In chapters 8, we looked at various sort of scientific phenomena that dealt with dilute solutions. For instance, when we're dealing with Henry's law, to look at the dissolution of gases in liquids, or at boiling point elevation, or even at osmotic pressure. We looked at these various situations that dealt with dilute solutions, and specifically, we used the chemical potentials in order to understand, how these systems behave at equilibrium. And when we wrote out the chemical potentials for the various species in these dilute solutions, we saw that the chemical potentials kind of had this form, where in the limit that xi is very small, goes to 0, mu I at some temperature, pressure, and value of xi was approximately equal to some constant term plus ln of xi RT, where this constant term was just a term that is not a function of xi, so independent of xi. Okay? All right, and so that's the functional form we saw for dilute solutions. And so in chapter 10, what we're going to do now is look at non-dilute solutions. So let's now look at cases where x1 is not dilute. Okay? And traditionally, there's sort of two different approaches for doing this in order to account for non-idealities in non-dilute liquid mixtures. Right, so two ways to characterize mu I. Okay? The first way is the activity method, and then the second way is the excess property method. Okay? And so these are both distinct ways of evaluating non-dilute solutions, right? But rather than picking one over the other, what we're going to do is we're actually going to combine both of these approaches. So we will combine both approaches. And by combining both of these approaches, we're actually going to develop very simple quantitative models for studying non-dilute mixtures. Describing non-dilute mixtures.